All right, here's the first example. Now this will be our last lecture. This is the last section for the entire class. Isn't that exciting?
Yes, it is.
So after this, all you gotta do is finish, take your final, take your test 4, and then you're done. You finish early, cool, and you can just not worry about it anymore. I'll just grade it as soon as I can. Um, but anyway, the last section, I don't mind if you use a solver for this or your calculator. I'm not gonna go deep into this idea because it's very short and it's not going to be applied. So, but let me first write this question down. So this is number 1 assignment. What section was this? 11.1 through 11.2, solving matrices. All right. So the idea here is understand how to convert from a system of equations into a matrix. And a matrix is basically another way to write the equations, and it also allows you to solve them using different techniques. So change the augmented, let me write this down, matrix second. The system of equations into an augmented matrix. Let me write down the question. So negative 9x plus 10y minus 6z is equal to 7. 10x, 5z, 5y minus 3z. There we go. So let me share the work here. All right, so what you want to do, if it's not already in order, is put it in XYZ form or alphabetical order, XYZ. If there's one missing, just leave a space. That'll help you make the matrix. This is X, 0, Y, Z, 0, X, Y, and Z. This is the augmented part. So when they say augmented, they mean this equal to part. So in the homework, what you got to do is put everything on the left-hand side. If it's already in this form, right, in order, everything, nothing but variables on the left, nothing but numbers on the right, in alphabetical order. Then the first column will be the X column, so negative 9, 10, and 0. That's the X's, right? So just take the coefficients, negative 9, 10, and there's no 0, there's no X here, so 0. This would be the Y column, so 10, no Y here, and then a 5. And then the Z's, 6, 5, and negative 3. Excuse me. There's rain's getting me. 7, 5, negative 7. All right. So that's all they want. So the equals to part is the augmented part right there. All the variable coefficients are go over here. So they also call this the coefficient matrix. Okay. Is there any questions on where these numbers came from and where you put them?
One question.
Mhm.
So this is you just took the variables, added some like 5z. That's 5z, right?
Yeah, that's a 5Z.
Okay. It looked like a 52 to me for a moment, but I saw the line.
Yeah, that's why I put lines through my Z's because they look like twos. I hear you.
And then after you kind of like put it together, then you're given that.
Yeah. So
All right.
this is all the X's, all the Y's, and all the Z's.
All right. That's all.
Okay. So that's all they want you to do is just fill this out. So that would be all those numbers. So that's number one. Let's look at number two and see what it's asking. Number two is the same type of deal. Let's just go ahead and do it here. But first check, are all the X's and Y's in order? Looks like it. So let's do the X's first. There's no X at the bottom. All the Y's be 2. Then no Y. And then there. -4, 4, -7. All the Z's. 2, 9, and -3 are your right hand side here. Anyway, any questions on where these came from? Same thing we just did before. Okay. Yes, it's just one section. It's the final section of the whole class. It's just about solving matrices.
Like one entire section of just that, but with different examples.
Yeah, it's just one homework assignment. That's all it is. Okay. Let's see here. And yes, Carl, if there's something missing, put a 0 as your placeholder. You can think of it as 0x or 0y, because that's what it is. Okay, so in this one, write the augmented matrix for the given system. You could have a two by twos, like a x and y equal to something, and so you would have a 2 by 2 system with the augmented part. But technically, this applies to n by n dimensions. You can go really large. And every time, technically, whenever you Google something, you have like million by million or billion by billion equations, and they're all being solved by a matrix. So when you're trying to find something, it's actually a solution to a matrix. Let's see here. So the first equation, so remember, we only have a constant here, -5. So I have a single x, and I have no y's and z's for the first row, right? The second row has nothing except a y, so 0 everywhere else. And then I have that constant. Here we got 0, 0, 1, and then it's equal to -10. So when it's in this form, you have -1, or you have ones down the diagonal. It's basically a solved matrix. So when you solve it, like the other ones we were doing, if we were to solve them, they would turn into this, which tells you what x is equal to. X is equal to -5. That's why you read this first line here. X equals -5. This is y equals -1/6. Z equals -10. That's how you would read that. You would change it back into into equations. Any questions on number 3?
Not that I know of.
Oh, here's a 2 by 2. So now they want us to change it into equations. Okay. So write this as sum. Oh, I see. That's what they want. Okay, well, there's the answer, but how did they get that? So remember the X column is this one, and every row is an equation. So this row here is negative X, right? Plus a 7Y equal to the 0. So we read it. So we're going backwards. This is negative 6X, 6Y, and 1. So negative 6X plus 6Y equals to 1. That's how you get these. So we're going backwards. Any issues going from matrix to equation or equation to matrix?
I think I might have messed up on one, but I'll probably ask about it later.
Okay. But yeah, just keep in mind. First one is the X, second one is the Y, and this is equal to whatever's on the right. So 1X, 1 negative X, 7Y is equal to 0. Right, so that's number 4. Let's go look at 5. So far, we haven't solved the matrix. We're just kind of transforming them back and forth. So here they want us to change it back. So this is a 3 by 3 system. What is the first equation? What do y'all think?
Someone said 1x plus 8y minus 5z.
Yeah, 1x plus, oops, what's the wrong button there? Plus 8y minus 5z equal to negative 4. Okay. And then the second row, there's no x, so you don't have to put it. Single y plus 3z equals 11. What about the last one?
Equals. Oh, wait, never mind.
Yeah, that's just a single z equal to 1. Oops, 3, sorry. Okay, so just the first 6 questions or so, 5 or 6, is just, can you change it from matrix to equations or equations to matrix? At this point, they want us to be able to, what's the word? Interpret the answer. So they've already solved the matrix on this question, but they want you to understand. So I'm going to make a note for you in a moment, but if you see a row of zeros followed by a number, that has no solution, because remember, this means what? 0 equals 3, right? The bottom part.
Yeah.
So 0 equals 3 makes no sense. But that's false. So you would say the system has no solution. If you see a row of zeros at the bottom, then you would say infinite solutions. And if you just have the ones like before going down the diagonal, that would be a unique solution, one solution. So let me make you a note real quick. Okay, so examples. Of solved matrices. So if you have 1, 0, 0, 0, 1, 0, 0, 0, 1, equal to some numbers, right? This is an example of a unique solution, meaning one solution. Yeah, something like this. Some numbers here, but the last one, or maybe the last two rows, have zeros. This is an example of infinite solutions. So row zeros, infinite. Now, if you have zeros and then a number, let's say I have 1, 2, 3 here. So this is an example of no solution. Okay. And then of course I'll send that to you in a little bit. So this one is obviously an example of no solution. Yeah, where's the next one?
Someone's asking to go back to the notes real quick.
Yeah, no worries. So what do y'all think about this one? What's the answer?
Someone said no solution.
That's close. But we have a row of zeros. That's scenario 2. So whenever you see a row of zeros, if all of them are zeros, it's going to be infinite solutions.
Infinite. Infinitely many.
Yeah. Okay, what about this one?
It is a row of zeros.
Yeah, still infinite, right?
Also infinite.
Yeah. You're right. Okay, see what's the next one. What about this one? Yeah, we have one solution. It's going to be unique, right? We have a one is down the diagonal equal to some numbers, so one solution. This has 2 rows of zeros. So this would also be infinite. So this sometimes happens. But as long as you don't see a false statement, assume infinite. If you see a number equal to 0, like 3 equals 0, that doesn't make sense. I'm sorry, I should say 0 equal to 3 or something like that. Okay, so this one's more conceptual. So a lot of complex questions can be turned into systems, which can then be turned into matrices. Let's read this real quick. Jessica went to Quick Trip, bought 3 large Dr. Peppers and 5 regular Snicker bars for $16.47. Brandon went to the Quick Trip, bought 2 large Dr. Peppers, 7 regular Snickers for a cost of $18.24. If X represents the cost of a drink and Y represents the cost of a regular Snickers, determine the system of equations that represents the situation. Okay. So the first scenario is equation 1. I have 3 of this plus 5 of this, and I get a total equal to this. I don't know what the price is, right? That's the unknown. X represents the cost. So 3 Dr. Peppers times the price of it plus 5 Snickers times your price gives you a total of $16.47. So do you agree that it has to be 3x plus 5y equal to 1647 for equation 1? So it has to be one of these. Oops, actually that's wrong. I think it's just A. Yeah. Because the next one says I bought 2 Dr. Peppers for some price, plus 7 Snickers for some price, equal to a total of this. So it has to be these. Any questions on how we create this equation here? Or how we got these? Yeah, just make sure you understand what is represented by what, and the coefficients were the number we bought, X and Y were the prices. This one's similar. Let's see. Well, let's go through this. Okay, so what they do is they make a little chart to keep everything together. So let's try to get the information out of the chart, out of the question. So the things that matter looks like we got two people, Brian and Jaden. They both had barbecue chips and soda. Okay. Brian had 3 ounces of chips and drank 1 cup of soda. So they put 3 chips, 3C plus 1S for a total of 800 milligrams of sodium. So that's equal to, right? So this is our first equation. 3C plus S. Oopsie. Um, equal to 800. Do you see how where this is coming from? You don't have to make the chart, but it kind of helps to understand. Then the next sentence says Jaden ate 1 ounce of chips and drank 3 cups of soda. So 1C plus 3S equals 400 milligrams. So C plus 3S equals 400. So that's how they get this. All right. Now, how do we solve a matrix or a system? I recommend using your calculator or a solver, but you can also do substitution, like back in the day. So I'm going to write the systems over here. So before I move on, is everyone comfortable creating the system here?
Yeah, looks good so far.
Second. So what they do, so they take equation 1 and 2, they say, you know what? We can do this a couple of ways. Take equation 2 and solve for C. So do you agree that if I subtract S over 3S, I'm going to get this, right? So then solve for C in 2. Then plug in C into the equation 1. So you have everything in terms of one variable, soda. So plug in C from 2 into equation 1. So we did. So distribute your 3, we get 1200 times this 9s plus s. That'll be negative 8s equal to 800. Subtract 1200 over, and we will get what? Negative 400, right? Divide both sides by 8. Negative 8. S should be 50, right? Double check there. This feels wrong. Yeah, that's right. Okay. So we got the milligrams for soda. And we know that 50 plus 3, what was he again? Chips, right? Yeah, 3 chips and 1 soda is 800 milligrams of sodium. If I know 1 soda is 50, then I can solve for C. So plug this into one. It doesn't matter which one. I'm going to choose 1. Let's subtract 50. So I plugged in the C, subtracted it over, got this, divided by 3, and we should be done.
Which question is this again on the assignment?
One of the last 2.
On the last two? All right.
Any questions on this problem here?
No, sir.
Okay, well, that's pretty much it for section 11. There's no more homework anymore after this. Do y'all have any questions on anything in general?
Uh, are we gonna? Is this like part of the final, or do we have like a final we're doing?
There's a final exam um, that covers everything. Yeah.
All right. But is this also? Does this assignment by itself have a test or a quiz or anything?
No, it's not on any exam, but you'll see maybe one question in the final about this.
Like, is it any question from here since it's sort of?
Yeah, I mean, it'll be the one that you see on the review or the practice test.
All right.
So I would focus on an example like that.
So just do the assignment and then focus on the review and all that.
Yeah, at this point, I say make sure your homework's done as soon as possible and exam 4, and just start reviewing for the final. That's all you got to do now.
All right. Sounds good.
Let me take roll and then we'll stop here. Just let me know if you have any questions.
Are all practice tests open to unlimited attempts?
I think they should be, unless I missed one.
They're not.
Did you check recently or?
Last time I checked, it was still 1 to 2 or 0 or 2 attempts, but I'll have to check again. Like if you updated it.
I think I did, but let me know if it's still not updated. I'll fix it.
All right. Yeah, the practice test has an unlimited attempts.
Okay. Um, so- oh, here it is. All right. Abigail Carranza here.